Sorry again here. Should we do a short presentation in the beginning of all of us, or should I mean not? I mean for the presenters, or how will that be?
Well, my proposal would be that yeah, I introduce myself and then I give over to Mohammed and he gives a short introduction who he is, and then the same for you.
Yeah, right.
That's okay.
Yeah, absolutely.
Hello.
And I understood that Annie will give a small introduction also of 2 minutes.
Yes, correct.
Yeah.
Yes.
So first Annie, then Elmart, and so. Okay, perfect. Annie, maybe it's good that you will mention that we are recording also.
Yes, of course. Yes.
Thank you.
I think we shall start. Dear guests, on behalf of Business and Technology University, I would like to greet you and welcome you to today's webinar, Innovations and Technologies in Relation to Industry 4.0 at Volvo, organized within the framework of EU-funded capacity building project HAIN4. We have participants connected from Belgium, Sweden, Portugal, Ukraine, and Georgia. Thank you very much to all of you for joining us today. Special thanks to the webinar speakers from Volvo Cars Gent and Sweden. Some housekeeping before we start. At the end of the webinar, we will have the dedicated Q&A session, and we would love to hear from you. Please be kindly informed that we are recording the webinar, and the recorded version will be available upon request. Now I'd like to introduce today's first presenter from Volvo Cars Gent, Mr. Elmar. The floor is yours.
Yes, hello. Hello, everyone. I'm Elmar Dermout. My apologies for my voice. It seems that I lost it yesterday. It's a bit better today, but if anything is not clear, please let me know. So I will share my screen. So I am a release train engineer within Volvo Cars for Industrial Operations Digital. So we deliver digital solutions for manufacturing and supply chain logistics. Can you see my screen?
Yes.
Yes. So first of all, we wanted to have a look what innovation means for Volvo Cars. The first thing I did, I looked it up on Wikipedia to understand what does innovation mean. So it's actually a new idea that is applicable for products, processes, services, technologies, and or business models. And it has an impact on markets, governments, and or society. It's actually a practical implementation of an invention. So why should we do innovation? There are, of course, many reasons. I picked 3 ones here, and that's to be able to enter new markets or create new markets, to stand out from competitors, not to be the first per se or to be the most competitive, but companies who don't need to invest too much money in competition-related things like advertising and cutting prices. They have more resources and room to invest back into innovation. And the third one is to attract the best talent. As you can see, these 3 things are actually enforcing innovation like a flywheel. So how can we do that? Again, there are many possibilities. 3 most important ones for us is teamwork, a mindset and culture, and management support. So for teamwork, if we look at our shareholder and chairman, Lee Shufu from Geely, he calls for more partnerships within the automotive. That was a couple of years ago, when we see that from Silicon Valley, the tech companies are growing really fast, are very innovative, and we want to have the same back again in the automotive like the last century. And you can see that this year when you listen to the annual meetings from the legacy OEMs, is that it's not only about electrification, but also about digitization. Also, we do some partnerships with companies outside our automotive sector. An example here is Didi, that's a Chinese Uber. We work together with them to be able to improve autonomous driving. And also internally, we need to make sure that we don't end up with a lot of silos. The silos, they may be efficient and effective within their own organization and product and services, but if we look at the whole holistically, then that is not as effective and efficient, since there is a lack of transparency, cooperation, interfaces. So we need to make sure that all the teams can work together holistically. An example of this is in Daicheng. There were some quality issues with the paint on the bodies, and therefore the paint shop production team collaborated together with their internal supplier, which is a body and white shop production team. So together they did Kanban walks in each other's processes, and through that cooperation, they were able to reduce their quality issues with a multiple of 3. Then we have mindsets and culture. So it's important that every employee within an organization has the chance, the ability to share their ideas and propose improvements. So the management needs to support this. And within Volvo, we have a we culture. So we are curious, we create together, and we make the difference. So and linked with innovation, what is important is that we learn every day so that we can innovate. We use our full potential, and we have no limits. So we break down the silos that limit us to contribute. And of course, also we care about people and the world we live in. An example of this is a video here. Let me know if you also can hear the sound. I will do the English subtitle. 1 second, please.
I'm Björn, and I'm here at Volvo to find out what is the ultimate safety test. These are the side and frontal crash tests. They're brutal. Yep, seems fine. This one is my favorite. The run-off road test. Impressive, right? But is it the ultimate safety test? This is the big one, the 100-foot drop. So is this the ultimate safety test? Well, it depends whether you...
So Volvo Cars has been very famous for its safety. An example of this is that we invented the 3-point safety belt in 1959. Yeah, now it's mandatory. We opened a patent the last century for every automotive company, so that every consumer could have the same benefits of safety. It has saved over 1 million lives. But now also we are focusing on the environmental impact, and we will go for full electric in 2030 and half in 25 together with hybrid. So that's very important for us. And yeah, so if we look at innovation to products, this is a good example. Another one is in services, the ability that a package delivery can be done in the trunk of the car without you being there. So while you're working, your package is delivered in your car. For business models, a couple of years ago in the LA Auto Show, we were the only car company that did not show any car at our stand and had a big banner saying, "Don't buy our cars." So what we want to go for is more going towards subscription, like which Spotify and Netflix does. And also we have innovation within our processes and tools. A couple of examples that I have been involved with is big data. So we're working on a project where the maintenance is logging a lot of data, which can help them improve and understand what is happening. At the moment, we're scaling this up so that we can go for predictive maintenance. Another thing is also the new ways of training by video and virtual reality. And we also use augmented reality for pick by vision and support from distance. So for example, a maintenance person that can get support from an engineer who is working from home. And lastly, also 3D printing will give us a lot of opportunities. And I will give the stage to Mohammed, who will explain more about some examples that we do within Volvo Cars related to Industry 4.0. Thank you.
Thank you, Elmar, and thank you for the invite. So my name is Mahmoud Bosch, and I work at the Volvo Car Torslanda factory in Sweden, Gothenburg. So my main role is that I'm responsible for smart factory initiatives, meaning that basically all projects that are related to Industry 4.0 within production. But I also have some projects ongoing within logistics and also connected to maintenance department. So once in a month, I have meetings trying to have globally together with colleagues within Ghent, in other plants in US and APAC, and we share best practice together because we don't need to reinvent the wheel in all plants if another colleague has already done it. So I'm going to present my screen. Oh, sorry. Let's see. So can you see my screen?
Yes.
Good. So a smart factory at Volvo Cars, some call it innovation, some call it smart factory or smart manufacturing or Industry 4.0, but in the end, we are talking about the same thing. So what does smart factory mean for Volvo Cars? And it's basically that we know that this new so-called era of digitalization, it will change the way we work, how we hire people, new type of competences, and so on. And it has been increased very rapidly the past year. The need of digitalization and optimization, and we know that this will affect us both internally and also externally. And I will explain a little bit more what I mean by internally and external environment. But for us, it's not always the new technology. Many people think that Industry 4.0 it's mainly new type of technology, but most of the new these technologies that we talk about, like augmented reality, virtual reality, 3D printing, all those technologies has been here for a couple of years. It's nothing new, but the mindset it's new. How we use them, how we integrate them in the plants, how we use them to improve our KPIs. So, but there's also new type of technologies within the IoT, Internet of Things area. But we try to use them to try to both use the existing and new technologies to eliminate everything that is not value added to our work, and also make our resources more efficient. And for us, just to add, VCT stands for Volvo Car Torslanda, by the way. And for us to be successful here, we need to be transparent and collaborative. It means that we should not hide too much in this type of era. We need to collaborate more and also show, like this type of webinars, present what we are doing more actively. And many people call this, we have a goal, we need to reach Industry 4.0 within a couple of years, but we don't see it as a goal, we see it as a journey. This is a improvement journey that will be here for a couple of years. And we also know that this will create new type of competences that we don't have within the plants, within manufacturing. A couple of examples are, as Elmar mentioned, 3D printing. We haven't had it within the manufacturing or within the plants before. So this creates new type of competence that we need to have, like a 3D application engineer. That is a new type of competence that we have today in our plant that we haven't had for 2-3 years. We have business intelligence specialists within our plants that we didn't have before. We have people that are experts on augmented reality and virtual reality. That is their competences. So this new, we call them new type of competences, they are needed today. And we also see that this will affect how the academical education will look like in the upcoming years. That it will be some kind of new type of, how should I say, new type of roles or new type of programs in the academical institutes. And how can we increase the knowledge in-house? We need to use our own facilities, our own academies, because within Volvo Cars we have so-called plant academies where we teach basic skills to our employees. We teach them also how to work in teams, and that I will explain a little bit more about our plant academies. But I mentioned internal integration. It means that we have a couple of departments within our facilities and within our company, and this is some of them. We have plenty more, but as we have noticed in the coming years that we need to collaborate within all departments because everything is integrated with each other. For instance, procurement. How will they affect us? Yeah, this new technologies. It's developing so rapidly that some technologies are old by 1 year. So you need to have new type of business models, which means that you have proof of concept contracts, so to say, meaning that we test and evaluate and we lend them back. An example is that you see the leasing opportunities. People don't buy cars anymore; they lease the cars. So this means that we need to collaborate more with procurement. We need to collaborate more with legal, but also our plant ITs, because we cannot do anything without IT anymore. IT is a very important role, and we notice that especially in these coming years when we need to use more data from our equipments, that how can we do it in a more cyber secure way without affecting the production environment? And we need to involve IT very early, and we need to respect IT because it's very important for the cybersecurity. Many people also here internally, when we started with this journey, was that, yeah, can we just grab the data and do some analysis, or can we just connect this sensor to production? But it wasn't so easy as we thought, because we know that when we are now opening up, everything is connected to the cloud, we get also more vulnerable, meaning that if you don't have a good cyber secured strategy, it means that it can affect our plants and our business also. So therefore, an internal integration and discussions with this department is very important for us. But as I mentioned, we also have external integration, meaning that if our colleagues in Gent, they are working with augmented reality, and we need to learn from them. If you are working with 3D printing, then they need to learn from us. We don't need to start by reinventing the wheel in all plants, and share best practices with each other. And academic institutes, a very important function that we need to use much more. You are a couple of years ahead of us within the researchers and so on. Our suppliers, we need to have good collaboration with our suppliers to see what's coming in the upcoming years, new technologies, and so on. But also our industry partners. For instance, in Sweden we have ABB, we have Scania, we have Volvo Trucks, SKF, and so on. Big companies that we can learn a lot from, and so on. So external integration is very important, key for us. The Smart Factory Academy, as we call it. The picture that you see here, it's basically one of our plant academy facilities. We have it in all our plants globally. These are wooden cars. We don't sell them to customers, but basically this new employees, but also existing employees, they come to this facility to learn how they can work in teams. So for instance, I don't know if you can see my pointer here, but yeah, this is the headlight, this one. So they learn how to assemble it, how to disassemble it, and so on. And also how to call for help in the production line when they need help. And also you can see the material facade and so on. So what we have done here is that we took this to a next step. We called it Smart Factory Academy instead of Plant Academy, meaning that we integrate these new technologies or this new way of working inside this facility to educate our employees on this new type of technology that we have. And some of the technologies that you can see that we are working with is, yeah, I will explain them a bit here. But why we use this facility, and it's basically we use it for experimenting and learning in a controlled, isolated network, meaning that we can do whatever we want without affecting the plant's cybersecurity. And this is also a facility for us to learn how can we use this technology in our business. But it's also for us to increase the awareness of these technologies to the rest of the departments. Because as you know, due to the pandemic, you cannot travel to events, you cannot participate in messes and so on. So we need to have something internally to learn more, and something that is based on our systems. Because yeah, it looks very fancy when you have a company coming here and presenting a technology for you, and it shows, yeah, this technology is very good, but we need to test it in our own environment to learn more and to see, will this work with our own systems and so on. So what we have done is basically we have installed some applications in this area, smart tracking, meaning that we can track all movable objects. We can create geofencing, meaning that when for instance, an operator is outside an area, it can trigger an alarm, or you can use it for auto login, basically like instead of writing on a paper, now I'm on this station, you have the tag on you and it knows that now I have signed into the station. It can also be used for tracking vehicles inside the factory, see where are they parked and where should they be. You can also use this data that is gathered with the smart tracking to see movement patterns or heat maps. How are we moving inside the plant? What is the best way to navigate our traffic inside the plant? So the smart tracking is an area that is going to increase rapidly in the upcoming years, especially within the plants. How can we track tools inside the plant? Are we using them correctly? And so on. We use drone for inspections. I will show another slide on that. We have digital team board that we are testing and evaluating, meaning that we are looking into the possibilities of getting rid of whiteboards and paper printing and so on, decrease our CO footprint. How can we use that data that is today on papers? As you know, that we have very useful data that operators write on papers, on whiteboards, but that data can be removed by a rubber, or they can just throw out the paper. So that data is not always saved, but by taking the step to so-called digital team boards, meaning that we can log everything that the operator is writing, all the improvement tasks or the problems that they have within teams. It means that we can use that data to do future improvements in our process. We can go back a year or two and see what was the most common words that teams were using, for instance, and so on. So a lot of this is mainly connected to data gathering and data insights that we can use for analytics later on. AR instructions or augmented reality instructions. How can we use digital instructions for our new employees? We know that the future employees are more digital natives, meaning that they are familiar with these tools. Therefore, we need to be also a attractive employee in the future or in the upcoming years, because all this new generation, they are very familiar with these technologies. So how can we give them AR tools to learn even faster, and also collaborative robots or cobots, the green one, as you can see. How can we use this type of robots to collaborate together with our employees without having huge security fences and so on, because these cobots are, you can stand next to a human and work together with you. And also connected to maintenance, we have our vibration measuring. How can we detect major breakdowns, meaning that we monitor the vibration from our equipments and trigger alarms before a breakdown can occur. Just to give you a number, the facility in Torslanda, we produce 60 cars per hour, meaning that we cannot stand still for a long time. Therefore, we need to be prepared. As Elmar mentioned, going to predictive maintenance is very important for us. We also have this remote assistance in this facility, meaning that we teach our colleagues how can we get support from distance by using AR headsets. How can we get support from like ABB or DUR from Germany? This pandemic doesn't let the technician travel a lot, so this remote assistance technology, it has been very useful for us in this hard time. 3D printing, I will present a bit more about that in the upcoming slide. But how do we use augmented reality and virtual reality? This is an area that has been increased a lot this year. We use it for 3 areas. One is for virtual plant view, smart production, and smart maintenance. As you know, we have a couple of new car models that are coming in the plants, meaning that we need to rebuild many areas within the factory to be able to produce these new cars. And how can we see the project as close to the reality as possible? So we have used a lot of virtual reality technology these coming years by using, like, for instance, HTC Vive equipment, adding plant layouts. We can design the layout and add it in the glasses and tell our manager, come down and see how it looks like. And the manager or the project manager comes there and say, no, I don't like that. Can you change that one? And so on. So you get a very realistic view of how it could look like. And it's very useful for us because it reduces our project times. It makes us it makes us how should I say, we don't take wrong decisions as we did in the past, because now you have a reality that is very close to how it would look like in the coming years. We also use it for virtual equipments, meaning that if maintenance is buying a equipment or production is buying equipment, we would like to see how will it look like inside the facility. And you can take that 3D model and put it inside the facility model and see and orient around the equipment. Gives us a good view of how it looks like. Within smart production, we are elaborating with smart or assembly instructions. How can we teach this new generation of employees in a better way? Because we have also an elder generation in our plants, and they have a lot of knowledge of how the process works and how to work. How can we use their knowledge and add and use this technology to present their knowledge to the next generation. We also use AR for virtual meetings due to this pandemic. We have had a couple of so-called Gembas where we have management where they were with us through the glasses when we had line walks inside the production. Smart maintenance, as I mentioned, remote assistant is very important for us as it is right now, especially for maintenance, getting expert help from distance. And also maintenance instructions. How can we teach maintenance how to perform inspections on advanced equipment that we don't always do, or we don't do it very frequently. We have some equipment that we do preventive maintenance like once in a year or two times a year. That makes it very hard to be expert on that equipment if you have not done it frequently. So by having these digital tools, you can add advanced instructions, or simplified instructions to repair or inspect equipment. Advanced robotics, also an area that we are working with. We have a drone. Many people think that, okay, what are you doing with a drone inside a factory? But we don't use the drone for producing cars. We use the drones for improving our KPIs, reducing our energy cost. We use it for detecting heat leakages. As you can see in the middle picture, we can take picture of how the facility looks like when it's leaking heat and so on, and you can see how it looks like. You can take plant views, meaning that you can take pictures from high heights to see how does the yard look like. We can use it for doing high inspections. In the past, we had companies that were having lifts, and they need to first get the lift and go up and see how it looks like. But today we can do it by a drone. We can also use it for security, trespassing, and so on, to have automated guided routes for the drone to see how does the fence look like. And one good thing with our drone, without revealing the name, is that it has a very advanced camera that can take pictures you take picture of the same object, the same position every day, and you can use the artificial intelligence inside the camera to detect abnormalities. If you have some abnormalities in the picture, so it can identify it, which makes this very useful. You don't always see with your own eyes if you have some problems on a specific area. Smart maintenance then. In the past, or I would say in 1-2 years ago, as many companies, we were having calendar-based maintenance, and that means that we each 5 weeks we do maintenance on the equipment. It doesn't matter if that equipment was running or not. We do calendar-based. Take for example your vehicle. You need to do your inspection on your vehicle once in a year. Doesn't matter if you run the vehicle or not. That is not so smart to do. But today we are going towards a so-called predictive or prescriptive maintenance. And predictive maintenance is basically that you can predict before something occurs, meaning that you monitor your equipment and you use the historical data to tell your system that this type of signal, each time it occurs, you need to do some action, or this will happen. And by prescriptive, you mean that basically you prevent, how should I say, you do tasks before even that problem occurs, meaning that if you have had if you do lubrication on an equipment each 5 weeks, we have a so-called recipe for telling the system that now you need to improve yourself, doing it 4 weeks instead, basically. And what we have done also is that we today we let the equipment ask for help. We use internal signals, sensors, or you can call it IoT if you want, but basically the equipment's own sensors to trigger maintenance events instead of the we have been 5 weeks maintenance. We tell the equipment when you have reached, let's say, 5,000 openings, then trigger a work order to our technician. It's basically the same as you have in your vehicle when you are running like 10,000 miles, and after 10,000 miles you need to do your maintenance, and that is more cost effective for us because we don't replace parts when we don't need to anymore. And this has also helped us to prevent major breakdowns. We have also installed a couple of wireless vibration measuring sensors on areas. We can monitor them from distance to detect abnormalities. For instance, if we see some strange movements on elevators inside the production, we can perform actions before the breakdowns occurs. So smart maintenance or maintenance itself, it's a huge area within Industry 4.0, and many companies are working very hard with this area, especially with predictive maintenance, because it can reduce the cost per car or cost per item a lot if we have the right strategy. Yeah, and the picture, as you can see in the right here, it is some example from our laser welding station in our body plant where we weld the vehicle. Here we gather a lot of data from the equipment, because today we are using a lot of data that has been generated for years, but we have not used them before. But today you have very useful tools like Microsoft Power BI or Grafana or Tableau and so on. These tools, they make it very easy for you to do data analytics. You don't need to be a advanced engineer or a data analytic to perform this type of analytics. So we use, in the picture here, you see a Grafana where we can send the equipment data and to see abnormalities. And also we can trigger like SMS to the technician or the engineer in the area when it reaches a level of, I don't know what to call it, but when it reaches a type of parameter, then you can trigger SMS, you can trigger work order to technicians and so on. So the data has been there a lot, but it has not been used. And thanks to this new generation of, call it Industry 4.0, but these new tools that has come up during this era, we can use the data and in a much more better way. 3D printing, we started this journey for like two years ago, and this was the result. We wanted to learn how can we use 3D printing to produce tools, jigs, fixtures, and also spare parts to our equipment inside the plant. So not producing 3D printing for the car, but for the production line. So the way we learned was that we need to have the equipment here to learn. And this is one example I always show. This one is basically that it by failing you learn a lot. You don't learn a lot when you just see some presentation or just read manuals. You need to really do the tasks also. So we had small printers in the beginning, and we learned a lot. And now we have taken a next step by working with more industrialized printers. We have gone from how should I say, filament-based 3D printers to powder-based, meaning that we can produce high-end end-use products that can be used in a lot of equipments. One of the examples that we always try to show is the picture, the black picture here with the black parts. They were previously on metal, and it was a very old equipment. But we had a maintenance engineer. He called us and asked, "Could you please see if this is printable? It's on metal, but we really need to have this part as soon as possible." So what we done was we did a 3D scanning because we didn't have any kind of drawings, and we 3D printed this one in the carbon fiber. And these parts are it has been inside that equipment for more than 1 year right now, and it's still running. So we don't have to have metal anymore. We can use this carbon fiber reinforced plastic instead. And also an area that we are working with is topology optimization within 3D printing. It is the picture here you see on the right corner. Basically, 3D topology optimization, what it is in basic terms is that you get rid of all dead materials that are not necessary. You use a software, there are multiple softwares. You detect where you have your forces, and you let the software calculate how much material you can get rid of, and you get a final part, and the part gets kind of homogeneous, so to say. And this reduces the printing time, this reduces the material uses, and it also gives the printed part very good mechanical properties, believe it or not. But when we get rid of these materials, the parts, they get really strong and so on. So this is an area where we use, where we are working more frequently. Another area that we are working inside the plant is so-called RPA, robotic process automation. Basically, it's how should I explain it? It's some kind of script, like how should I say, like PLC programming, but not towards PLC. But you can use this robotic process automation to reduce the repetitive administrative work. An example is when we have SharePoints, we have activities inside our intranet. We can create scripts that can automatically gather data from a site and send an email to a person and with that data. And it can also, this script can also go inside systems to gather data and send it by email to you, and vice versa. You can schedule tasks by having triggers. For instance, if you have some kind of every Monday at 10 o'clock, send emails to all these employees, or look who's inside the plant, and so on. And we have been using this very recently, and we have noticed that there is a huge potential of reducing the administrative work, the repetitive work that is not really value added to our process and so on. Yes, and I think that was my last slide. We have many other things ongoing, but I cannot, unfortunately, not reveal them yet. But if you have more questions, then we can take it separately. Thank you.
Thank you, Mohammed. Next person is Jan Carlson, who will explain a bit more how we use blockchain within Volvo Cars.
Hello, my name is Jan Carlson. I'm working at Volvo Cars procurement department, and especially with sustainability and with responsible mineral sourcing. I used to say I have a super interesting work. So working mainly with the battery material that we have, and as Elmar also show here on the film, that we are changing over to electrification here, and that is a large change going on, and in a very, very short time. I will do a presentation about our traceability system and how we are implement that and what this mean. You know that blockchain is a typical buzzword, and it can be used in many ways. But I will try to explain what we have used the traceability and the blockchain for when it comes to battery material. I hope that you can see my screen, otherwise you have to scream.
Yes, we can see that.
Great. First thing is that we did a large sourcing program for a couple of years ago for our battery electrical vehicles, and we should select a battery cell producer. And we from sustainability, our department was involved to assess the supply chain. And the reason for that, I don't know if you remember, there was a large amnesty report. I think it was produced in 2017. This is what we die for. And that is really the startup for the responsible sourcing of cobalt, for example. We start with that. And Amnesty was following the truck from a typical child labor place into a CDM facility in DRC Congo, and ask the OEMs and the battery cell who was directly connected to that manufacturing site to understand what are you doing to prevent child labor, for example. And that is two typical questions we did always get. And how can you be sure where the material is coming from, and how can you be sure that is no child labor involved within your production? So we know that there is a huge risk within the cobalt production, especially from DRC Congo. And when we visit the battery manufacturing, and we also visit the cathode and the precursor, we find out it was very much short contracts, and they was switching supplier in the supply chain very frequently. And we said that should we have any control over this, we need to implement some kind of traceability system. So that is a little bit background and answer the question why. Now I will try to, yes. See if it's working to change page. Oh, here it comes. So first I will show you some, I will not say boring, but you know, this kind of page to understand how does the solution work and the technology and so on. And but I think it's good to have that in the beginning anyway. Important is to understand that we are absolutely tracking the material, not the paper flow, because there are some blockchain working as well, and they are following the paperwork, and we are actually looking at the commodity itself and the material. And we are using different kind of systems, face recognition, GPS, and of course, also following the shipment, the logistic, and also in each process, what's going on. Yes, there are collection of data and supply chain mapping and data collection, a lot of scanning points. I will come back and show you that. And of course, there is an analyze we're doing in the end as well to understand if there has been some red flags setting, if some material are missing, take too long time between 2 points or something like that as well. So it's about to get a reliable track and connect the input material to the output in production and within the production steps. So, for example, in one production step, we are measuring and scanning goods in. And when we start with the production, we are also scanning that we are starting now with the bag, for example, and that could be split up in different batches. So we try to find in each place where are the right scanning points and how is the process working. And of course, in the end of the process, we are also scanning the outgoing goods. And so we have a very clear understanding, 1 ton in, for example, how much will that be for outgoing material? And then we're following the transportation to the next step. To show that a little bit more hands-on, you can see we are following, for example, here a supply chain with the LG Chem. We are starting at 0.6 in the below here from DRC, Congo, and we are shipping the material up to China, to Ohio. And here you can see the different scanning step we have in the fine refiner and the precursor and the cathode material, and also in the cell manufacturing process, always to Luqiao here, goods in. And to see a little bit more clear here, we coming into China, different locations, in this case to South Korea, and back to LG Chem in China again, and to our production facility in Luqiao for this specific example. So in the end, when we have produced a car, there will be an identification number of that car. So that specific car with the battery vehicle, for example, is then we can follow all the way back for the cobalt material within Volvo Cars, within LG Chem, within POSCO, as I show you here, within Ohio Cobalt for precursor material, for the fine refinery, and all the way back to CDM, and which bag it was started with in the beginning. So what I have shown you right now is from Volvo Cars to the battery pack, to the cell modules, to the cathode material, precursor, and cobalt. What we also have in place is within the battery pack, we also have thermal barriers, and we are scanning the mica material, which also have a very, very high risk for child labor when it comes from Madagascar or India, for example. And we are taking ours from Murmansk, actually, as a tailing material. So we have done audit and implement that traceability system as well for mica. Right now, we are expanding to lithium and nickel, will be onboarded before vacation, and later on the rest of the material as well. So here you can see the typical supply chain. And in the bottom here is what happened in DRC Congo. And the reason I show you that is because here is absolutely the highest risk. I mean, if you see from Ohio Cobalt right now, they have a joint venture with POSCO, and POSCO have a joint venture with LG Chem, and there is sort of more or less pipeline from one of these into next one. But incoming material to China has many different suppliers, and also according to OECD, it's a huge risk that material are mixing down in DRC, for examples. Here is an example of the large scale mining. It's permit here to excavate, that is the mining number we are taking material from. And this is meaning that it's artisanal and small scale mining with different places that we are involved in as well. And I will show you the reason why, because that is typical where the people are working, that is in this artisanal mining. And if I show you the next picture here on that large scale mining, you can see there are a couple of people, there are some trucks and excavators, and here is a very low risk for child labor, but it's also not that many people who is working in this industry. The outcome will be copper. Typical here, it's pure copper, 99.99%, and the rest product is cobalt actually. So that is not the main production, it's the rest product. And this material, the cobalt, will be packed here in different bags, 650 kilo. There is a typical bag number and a batch number. So that will be packed in container and shipped to China. But of course, material can come in from different places. So here is, for example, artisanal mining site with a trade station, and the truck are coming in there, and they can buy material much more cheaper. They can buy it. Some places have illegal mining, and they can buy it and drive into their crude smelter and refiner place and use that for to show it like clean material in the future. So we have been involved in some of these artisanal mining places because traceability without action on the ground, without monitoring to see what's happened there, and good action, that is not I mean, it's not worth anything if you know where it come from, but not make sure that it's responsible sourced there as well. It's not worth anything. So we have tried to implement traceability on the truck here as well. Is a fence around these artisanal mining and so on. And we're also using a third-party company, RCS Global, to have monitoring on site. Every day it's people there, and they are recognize what's happened because we have what we call responsible artisanal mining. I mean, that doesn't mean that we have risk and things are happen. So we know that there is always a challenge. You can see working condition here is a huge problem with using the right protection equipment, security, human rights, and we are monitoring and improve and put in corrective action plan all the time here to improve the situation. And you can see there is, if you take some, for example here, working condition, risk remote recorded incident, that is of course that protective equipment are being recorded well, and it's not use of this personal protection equipment. So that is a very high, when they're going down, it's super hot, and you tell them to use the helmet and so on, of course, but it's always a challenge. I will also show you what we are doing as a next step, not only to implement the rest of the material, but also to trace the CO2, because you can't drive a diesel combustion engine, for example, 2 years to have the same CO2 footprint as your production of one single battery for a typical battery electrical vehicle today. So that is very important for us to have a much more less CO2 footprint in our battery supply chain. So we are starting to trace the battery and the CO2 footprint in all the steps down from the mine to understand what kind of emission created in the production process and what is the CO2 inherited from the suppliers in the supply chain. So we are following the different step and add also the additional CO2 production in each step to in the final add up to a final CO2 footprint for the battery. So as an example here, it can be 1 ton coming in here in the beginning as a heritage of the CO2 footprint in one process. And then we start the production, doesn't increase anything, of course. It's split up here perhaps in 4 batches. And in the production, it could be a heating process, for example, for cathode material. We will have to add 1 ton CO2 for each batch, for example. The yellow here is material going to other OEMs, for example, in the end. So that will not affect Volvo Cars. So we will do the traceability and compare the total footprint for that process and use it for the volumes going to Volvo Cars. And the goods out then will add on this extra CO2 footprint, and also the transportation will be included here as well. So it's a challenge. We have a lot of things to do, but we have absolutely decided that we should have responsible sourcing, both when it comes to ethical and social, but also when it comes to climate action and CO2 footprint. So I think I stop there and hand over the presentation and open the floor for questions and so on.
Thank you very much. First of all, many thanks to the speakers for the insightful presentations. Now we have some time for questions. Dear guests, please feel free to turn your microphones or just send the text in the chat box, and the speakers will be able to see it and answer your questions. Thank you in advance.
May I ask a question?
Yes, Professor Shatocha.
Thank you very much. Well, first of all, many thanks to all the speakers for wonderful presentations, very informative and very interesting. And also many thanks to Ani as organizer. I very appreciate this. I have 2 questions actually for second and for third speaker. Let's try maybe from third. I didn't get exactly, do you have any figure for the this upstream carbon dioxide emissions per 1 battery, let's say? Is there any exact figure or approximate figure that you can tell us?
For who was the question, you say?
To you, yeah, about the carbon footprint. So do you have like some approximate value for the total or upstream carbon dioxide emissions associated with production of 1 battery for 1 car?
Yeah, we have a target for 2025 that the carbon oxide footprint for each battery should be down to 2 tons. And that is a huge challenge to 2025. I think we are where we are today. It's very, very difficult to answer. And that is something we will try to find out. But many people say that a realistic target would be to come down to perhaps 4 ton, but we have the target for 2 ton for the batteries, and for the complete car actually 8 ton. So I mean, if we are going up to 4 ton, then the battery will take half the production and of the target for the CO2 footprint. So it's a tough work we have there, but to be able to be reliable, to really have control over it, I also think that you have to know what is the actual situation. That will be updated, I can say, monthly about the CO2 production in each step. So we have the chance here to follow the changes we are implementing and so on, to really follow what is the actual footprint in each step and do the right action on the right places.
Thank you very much. Yeah, it's very interesting. Thank you. I have a question to the second speaker also, if possible, if he is here with us. The question was about cobots. I understand that you are using cobots, and I'm curious, do they have like learning algorithm? And if yes, what happens on the way? Do they are they getting more skilled with the time, or how it's happening with cobots?
No, I'm not a robot expert, but the cobots, especially the one that we have here at us or at our facility, they are very easily programmed, meaning that you have some kind of drag and drop programming by programming blocks, and of course you can add external sensors like 3D scanners for it to identify if to trace an object. For instance, if you move the objects and it cannot find it, and then you can use the scanner to look for where the object is. So yes, they are getting smarter and smarter, but in detail, if they are using algorithms or not, I cannot answer to that. Sorry. But the external sensors, they are getting the vision systems and the 3D scanners and so on. They are getting very smarter with inbuilt AIs.
Okay, interesting. And I have also a general question, final one. What is the major incentive for this transformation from selling cars to leasing cars? Are they getting more affordable? Are you getting more customers? So what is the main reason for that?
No, I'm not in that area, so it's hard for me to answer to that. But it's I think the business model it's not only for manufacturing. It's let's say for companies, when we purchase computers to our employees, we have leasing contracts for computers. We have leasing contracts for the screens and so on. I think it's that the new generation of people, they like to have everything served, so to say. The new generation, they are not very good at repairing the vehicles as the older generation as they are. They want to have things ready and served, so to say. So many people they would like to pay some extra just to have this how do we call it, comfortability, or also, so to say. They don't want to go to the mechanics. They would rather pay some extra fees on each month, and also have the opportunity to replace their car each 3 years, so to say. And I think also it's much connected to that you don't want to bound your money to a vehicles. But yeah, I don't know if it was a good answer to it, but
it's interesting. Yeah. Actually, I just invented a new slogan for our university. Don't enter a university, just subscribe.
So yeah.
Okay, thank you. I have no questions anymore. Thank you very much.
Dear speaker, we have another question in the chat box. What is your approach through cybersecurity field, or have you implemented WP23 regulation for safety?
I'm not sure if anyone, the three of us, has a lot of background on that one. So I'm afraid, at least from my side, I don't think I can answer that. I know Jan or Mohammed.
And the information we have in our, I mean, the recommendation from OECD and others is that we should be public with the information, so we don't have that, see that as a big risk. I mean, of course, we have an NDA and we are securing the material and have it in a quite secured way inside the European Union. At Frankfurt, actually, we have the servers, and we try to be as careful as possible anyway, because each supplier, I mean, treated their information like confidential, and they don't want, we cannot see information that's going to other OEMs or something like that. So we can only see information going to belong to Volvo Cars. So it's our provider Circular who has done that security when it comes to blockchain traceability, and it has been checked with our IT people as well. So we try to have as good security as possible, but that, I think, is always a risk, and you should not negotiate or negligate that. So it's a difficult but interesting question.
Thank you very much. Dear attendees, do you have any more questions? I see we don't have, the attendees don't have the questions. So this concludes our webinar. Dear speakers from Volvo Cars Gent and Sweden, it was a pleasure to have you with us. Special thanks to Mr. Barthoin for supporting us to organize this webinar. And dear attendees, thank you for joining us. Have a lovely day ahead, and bye-bye. Thank you.
Thank you.
Thank you very much. Bye.
Bye.
Thank you. Bye.
Thanks a lot.
Thank you. Bye-bye.